everyone, welcome to another tutorial. We are going to be talking today about the G1000 system. The video today is going to be narrated by our instructor Mateo. For about the first half of it, he's going to be narrating and I'm just going to be showing you hands-on in the RealSimGear G1000 complete system. After that, he's going to show you a couple of different systems between different aircrafts, and then he's going to take you on a flight and do a little like sample takeoff, departure, and approach using all the G1000. I want to thank RealSimGear for sending us this system to have a little bit of a hands-on training with you guys as well. I will say that it's a bit of a feedback. We've used their systems before, like the GTN 750, the GNS 530, 430, and some of our trainings. We use it in our cockpit as well. And I will tell you that it makes the biggest difference whenever you're able to feel the knobs and press buttons versus it being in the cockpit or in the virtual simulator. I know we cannot all afford it, but if you guys are ever planning on starting your own system, your own little cockpit, you go ahead and make sure you check them out at realsimgear.com. I can promise you it will make the biggest difference in the world. So without further ado, let's go ahead and get started with this video, and let's bring Mateo in. Okay everyone, just one more thing before we get started on the video. Be sure to check out the realsimgear.com website. They have a ton of cool things like the G1000, the GTN systems, the GNS, autopilots, just a lot of stuff for you to get your hands on. One more thing I want to point out, I did forget to put the plate behind the communication panel right in the middle. That is my fault. They do have all of that stuff on their website. So again, be sure to check them out at realsimgear.com. And for real now, let's get started.
Hello, I'm Mateo. I'm a flight instructor with VATSTAR. I'm currently a commercial pilot with multi-engine ratings working towards my ATPL. And today, in this video, we're going to talk about the G1000 system. The G1000 is a system that integrates all the various flight instruments and navigation communications equipment that the pilot interacts with and displays them on the LCD screens in a clean and unobstructed manner. So, this simplifies the aircraft operation and navigation and allows the pilot to focus only on the most pertinent information. The G1000 setup typically consists of two displays, one called the primary flight display on the left, or PFD, and the other one called a multifunction display, or MFD, on the right side. Between the two displays is an integrated communications panel. This panel, along with the two displays, allows the pilot to interact with the system through buttons and rotary knobs and allows multiple changes in the system. The rest of the system, where all the magic happens, is contained behind the scenes and consists of various computers, components, all working together to give you what you see in front of you. Now we're going to talk about the primary flight display. And to start off, I'm going to talk about the basic instruments on the primary flight display. The primary flight display is the basic flight instruments, but a little different from the old round dials that most people would be used to. It is still relatively easy to understand. Starting from the center of the screen, you'll find an attitude indicator. It looks almost identical to that of the original instruments of the older aircraft before glass cockpits. The big difference is that the horizon bar in the background takes up the entire screen. This really places the necessary emphasis on the instrument so that the pilot can still see it when focusing on different instruments. Now to the left we have the airspeed indicator. Instead of a dial, the instrument is depicted in a vertical tape format. Plus, at the bottom of the tape, you get the airplane's true airspeed. The G1000 automatically calculates this based on the outside air temperature and the indicated airspeed readings it's getting. On the right hand side of the screen, we will find the altimeter and vertical speed indicator. Like the speed indicator, these instruments are also displayed in a vertical tape format, and at the bottom of the tape is the altimeter setting where the pilot is selected, and at the top you have the altitude that the pilot has selected to bug. This places a small marker also next to the selected altitude on the tape to help remind the pilot of the altitude they are trying to maintain. or what the autopilot is set for. So for example, right now it is set at 7,800. I will bring it down to about 400 to indicate the marker. Immediately to the right of the altimeter is the vertical speed indicator. Instead of tapes sliding up and down like the previous instruments, the black marker is what slides up and down to indicate the current vertical speed. Unlike the older round-out versions, the instrument displays the vertical speed almost instantaneously. And then lastly, to round off our main instruments, the bottom of the screen is the heading indicator, although in this case the instrument is referred to as the horizontal situation indicator, or HSI. It can be thought of as a heading indicator with the addition of a navigational capability displayed in the center of it. Just like a compass card, it spins around and it shows your current heading, and then there's a numerical display at the top which displays above it as well. Our final instrument, which is quite small to see, is our turn slip indicator. The turn slip indicator is at the top of the bank angles for the attitude indicator, and this is indicated by a bar beneath one of the triangles. This bar deflects either left or right and indicates which side more rudder is needed to be applied to counteract and bring the aircraft back into coordinated flight. We've talked about the basic instrumentation of the primary flight display. Now let's talk about the navigational aspects. For the navigational aspects, it is split into multiple sections. At the top, we've got the GPS section, so indicating our active waypoints, our next to waypoint, our distance to said waypoints, and our bearing to said waypoints. Beneath that, in the HSI, we've also got the GPS and navigation information on the HSI, indicating where the GPS would like us to fly to, with a deviation bar in the middle, showing us where, if we are left or right of the track that has been selected. If we were to change things in the navigation of the PFD, we would do it by clicking on the flight plan page over here, and we will come to that later on as we delve into the flight planning aspects. But for now, that concludes the navigation portion for the primary flight display, and we move on to communications. Communication is handled in multiple ways on the primary flight displays. You've got the nav1 and nav2 for VOR tuning. You've got the COM1 and COM2 for VHF tuning of the radios, and in your aircraft is equipped, you have also got a DME function. In this case, we will come to that later on. Now we're going to talk about the communications portion of the G1000. The G1000 communications is done by the nav1 and nav2 and the COM1 and COM2. But before we go any further, the G1000 is based off of a color system. So in this case, green being for communications, so radios, VHF frequencies, so in the case of nav1 and also COM1s. And also, as you can see in the HSI in the center of the screen, VOR1 is also in green. Now if we see magenta, that means GPS, so indicated by the top bar here where it's blank, but the magenta indications mean that that is for GPS functions, and if I switch over the CDI to GPS, magenta again comes up for the GPS, but we'll keep on comms for now. So with that said, for green and magenta, we also have blue or cyan. This is where the pilot enters information or adjusts information as necessary to help him operate the aircraft. So in this case, in our nav1, we've got a blue box around this frequency, meaning that we can edit it, or in the case of COM1, it's around this frequency, which means that's the one we're trying to edit. In the case of QNH or altimeter setting, it is also cyan, which means we should edit it. And in the altitude bug windows and heading bug windows, it is also cyan, which means we should edit it. Now, starting off with the nav1 and nav2, we can use rotary switches on the outside to edit the frequencies, for the larger knob to edit the larger numbers, and the smaller knob to edit the smaller decimal numbers. Once we are happy with what we have got, we will simply press the transfer button, indicated by that also blue arrow there, and it will transfer that to the active, which is in green currently. At the moment you saw, it currently is not tuned to any VOR, so it will give no indication of it. But if I transfer back to give Astoria, the G1000 is smart enough to recognize that is Astoria VOR, and the code is Alpha Sierra Tango. And you can see it has also activated on our HSI, showing a deviation bar. Moving on to the COM page, correction, the COM side is the exact same as the nav side. Only difference here is that instead of just a transfer switch to transfer it between the normal comms and say Unicom, if I were to switch this frequency over, so it's not the emergency frequency, I can press and hold the transfer button and we will get the emergency frequency put into active of that. Again, same can be done with COM2. If I were to switch over one more time and switch to random frequencies, I can press and hold and again put the emergency frequency of 121.5 into the active. Now going back to the green. The green is what is currently active. In this case, if I switch CDIs to VOR2, that becomes our next active VOR. If I switch back to GPS, neither one is active, telling us we're not navigating off of the nav sources of the frequencies. And if I switch back again, it goes to nav1, indicating that's the frequency we're using. In the case of the COM menu, it is the same story. We've got 121.5 in green, which indicates we're using COM1 as active. If I go here to our integrated communications unit, I can switch to activate to COM2, and then vice versa to go back to COM1. Last but not least is our HSI in green over here, which will just indicate where our source is. So in the case of with the VORs, we can press the course button. In this case it says push course to center, and it will automatically point us just to where the VOR is. Should we need any more information, or we want to know where the VOR is without adjusting a course that say we want to fly, we can always bring up extra information by pressing our bearing selector buttons in the PFD screen, and we'll get to the options at the bottom in a moment. But like that, we've got information for VOR1, indicating by that arrow, and VOR2, or NAV2, indicated by the larger arrow with the space in between it. And these RMI needles just point towards the VOR. The G1000 primary flight display has extra functions in the form of buttons littered around the bezel and soft keys as well. So to start off on the left hand side, everything is labeled for what its function is. As we've just covered nav, we have the nub buttons to control it, as well as to change the frequencies, and then they also have a push function indicated by the smaller extra. In this case, all further functions are written here. For example, here push for 1 to 2, and that changes the standby between nav1 and nav2. Again, also here is a volume button. We can also a push to ID. In this case, if we want to hear the Morse code, it's a very faint one, but you can hear it. And then we can just push it again to turn it off, as well as an extra way of doing it is by just clicking nav1 on the integrated communications panel. We'll take one step further down and we've got our heading selector. We can rotate it to give us different headings as per the blue information that's asking us to put in. If I press it one more time, it does push to heading sync. One step further down is our altitude selector. Again, larger knob controls larger numbers, and smaller knob controls the smaller numbers. So in this case, that's controlling the thousands, and that's controlling the hundreds. Moving over to the right side, we have a similar setup with the comms buttons, similar to the nav, so I won't go over those again. But here we've got a course and a barrow. So as you can see, the course has a line going towards the triangle, which means our course will be changed by us using the triangle. And our barrow is a half circle around it, which indicates it's the larger one on the outside to control our altimeter. Taking one step down, we've got our range, which is a function for the inset map over here on the left, where we can adjust the range as necessary. Last but not least of the rotary functions is the FMS. The FMS has the larger knob for more of a scrolling function, and then the smaller knob is more of an edit function. We shall get to that in just a moment. After that, we've got soft keys along the bottom. So starting off with inset, which we can click into and choose different options for our inset map. The primary flight display, PFD, indicating different options we can set here, such as wind, DME if we'd like it to show, bearing 1 and 2, or adjust them to be GPS, or nothing at all. We can also set our altitude units, so if you'd prefer it to be hectopascals if you're flying in Europe, or inches of mercury if you're flying in America. And then you can have a set standard barrow for when you are flying above the transition altitude. Moving along, we've got the CDI, which transfers our source for navigation. In this case, it's Bureau 1. We can click and click again, and then we can click through up until GPS, and then it repeats back from Bureau 1. DME, if your aircraft is equipped with DME, we won't worry too much about it, as it's usually more automatically tuned once you've tuned your VORs, but in this case you can manually tune it and select different modes for it. Transponder, XPDR, in this case for when ATC gives you a transponder code that you should be squawking or different modes to change. In the case of VATSTAR, you'd click here and you would select your different modes, whether you are on standby on the ramp, on, or altitude when you're flying. You've also got a VFR button, which automatically, once pressed, will transfer the transponder back into 1200 for the American VFR code. If we press code itself, say ATC gives you a specific squawk code, you can then type in your related squawk code as necessary. For example, if you have an emergency, you can type 7700. Though this is not really looked greatly upon on VATSIM, but most air traffic controllers would be accepting of it. Last but not least, we've got in the transponder the ident button. Should ATC require you to let them know where you are, they will ask you to squawk ident, where you will then just press the ident button. In this case, if we turn it on to altitude and press the ident, it will form a little ident ping towards ATC. Next, we've got the timer and references, which gives us a little timer, and we can set in our minimums for instrument approaches on the system. Forming the second last bit of the soft keys at the bottom is the nearest page, which simply just shows you the nearest airport you are to. In this case, we are at Astoria, but we have not put that in. It will show Astoria as our nearest airport, and then following on from distance, the next closest airports. If we want to scroll through and see anything further than that, if they're not on that list, we can use the FMS button, as I said, for scroll function, and scroll through the list. And then last but not least, you've got an alerts window, which will give you alerts as necessary if, for example, you're approaching airspace class Bravo, as a warning as a helping hand. And finally, the thing I forgot to mention is a CAS window, which gives you information to the right side of the vertical speed indicator in case you have problems. So in this case, if I idle our 172, the engine is now spooling down, we should get a low vacuum alert and caution message popping up, as well as warnings would be in red if there were any warnings. So in this case, if I were to just turn off the alternator, we have now got a red warning and a low volts warning. But I shall remedy this, and the system is smart enough to recognize it, so if we turn it back on, it is gone, but it still needs you to cancel out that you had a warning and that you've acknowledged it. Same thing with the cautions. We can clear cautions, and then we can still have the alerts staying up so that we know if there's anything else that's new, it will pop up in the alerts. Now I'll just add a bit of power into the aircraft, and our low vacuum warning goes away. Caution. Next, we've got our 6 soft keys on the right side here, indicating menu, the flight plan, procedures, clear button, and enter. So in this case, the direct to button is as simple as it says. Direct to, it pops up this page, and you can automatically type in, you can scroll in what information you want. So if I scroll with the larger knob, it doesn't do anything. This is now where our smaller knob is required to put in specific information, so letter by letter, followed by the larger knob to then scroll across, in this case Alpha, and then I shall scroll again across to Sierra, and I scroll on the larger knob and then smaller knob one more time to Tango, and that would give us Astoria, and we would press enter. It will then highlight activating, basically saying, do you confirm you want to go here? And we shall enter again, and now we can see our GPS indication has gone active as our next waypoint, our distance, and our bearing. So with that said, we have other options that we can do. We can now click on flight plan. Currently menu is only active once you're in a sub-menu, so in this case we've clicked flight plan. We can now click menu if we want to do other functions, and scroll wheel through the different options in the menu, such as activate leg. We can store the flight plan, we can invert the flight plan, say if we've gone to a destination and we want to fly back the exact same way we went there, just invert your flight plan. We can delete the flight plan, load airways, collapse airways, delete approaches, create offset tracks, and so forth. If we wanted to add a new waypoint, we would simply scroll down one and then add letter by letter the waypoint we want. In this case we don't want to, so let's show the other button. If you didn't want to enter something and you accidentally went on a page that you didn't want to go to, you can just press clear and it will not clear it. If you want to delete a specific waypoint you added by mistake, you can highlight it, and then you can press clear and it will ask you if you'd like to remove it or cancel. In this case I don't want to remove it for now, and I will press cancel and then enter to confirm it. The next page we show you is the procedures. Over here you've got your basic functions to load, select approaches, arrivals, and departures. Obviously you've also got activate vectors to final, activate approach, activate missed approach, but those are all grayed out because we don't have anything loaded for them to be an option to use. And that concludes the primary flight display portion of this tutorial. Now we have the multi-function display, or MFD, which mirrors a lot of the functions of the primary flight display, since the G1000 is a integrated unit. So in this case, starting from the top, we've got the nav1 and nav2, similar to the primary flight display, and the com1 and com2, again similar to the primary flight display, with its associated rotaries and buttons similar around the bezel. The difference here mainly for the multi-function display is the autopilot control panel, which we will cover at the end of the video. But for now, majority of the system remains the same, with emphasis on engine gauges and systems and electrics, as well as the inset map has been significantly largened and showing more information in more clarity. So to start off, we have the system soft keys. In this case we can click it, and in the Cessna 1782 nav3 we have a fuel increase, fuel decrease, or reset fuel. This is because in the aircraft it uses electrical sensors to sense the fuel, and we have to press the functions to increase or decrease, letting the system know how much fuel we have on board so it can do its calculations. The next we have is the map, which is similar to the inset button on the primary flight display, which just allows you to change functions for the navigation display, such as adding terrain, airways, or NACSRAD information if you would like weather. Then, lastly, we have the declutter function soft key, which once clicked allows us to declutter the information at 3 different levels, and then back to original, which shows all the information such as waypoints, VORs, airports, and airways if you have them turned on. From there, the next thing the multifunction display does different compared to a primary flight display is the FMS button has functions automatically built in, meaning we've got pages and chapters on the multifunction display. The larger knob is for turning the chapters, and then the small knob turns individual pages in those chapters. So starting with the larger knob, let's turn a chapter from nav to the next one, which is waypoints. Or we can turn another chapter over to nearest. Now in the last two, at least on this aircraft, we don't have any other pages to turn through on that chapter, but in the case of nearest, we've got other pages. So in this case, we can now use the small knob and turn through the individual pages. In this case, at the top it says the nearest VOR, or the nearest NDB, the nearest intersection or waypoint, and the nearest airport, unlike the primary flight display, in more detail such as the airport's name, runways, frequencies in use, and etc. Now if we go to the back one to the waypoints, we get again information similar to nearest, but this time we can individually choose our waypoint by simply clicking to push the cursor. It highlights, and then we can edit information if we would feel necessary. In this case I cannot, because that is our only waypoint in the flight plan. And then now we come back to nav, which is our main functionality there. Just like the inset map, we've got the range button and panning. So again, we can zoom in for range and we can get the airport layout, or we can zoom out and get more information as we further zoom out from the system. If we wanted to, we can do again just like the inset map, push in the button, the knob, and then we can pan across to different parts. So for example, we can see down our flight plan if we'd like to. Push it once more again and it should return back to the aircraft's position. Next, we have the menu. On this one, we can use the menu to change how the display is. At the moment, it is currently north facing up. If I were to click menu, we have the option to press enter on that what is highlighted, and we can have track up, which is where our nose is pointing, versus where compass north is. For now, we'll keep it in track up, as most pilots seem to prefer that, myself included. From there, we now have the flight plan page. In this case, similar to the flight plan page on the other display, except here it shows a lot more detail and allows a few extra functions. Again, just like as before, the flight plan is the chapter, and we can also turn an extra page. In this case here, these are other flight plans I have loaded up in the background, and I can load one up automatically. So clear does the same as the primary flight display. In this case, we've got clear to hold for default, so it will automatically turn you back to the map. So if I go back to flight plan and say I wanted to go back to the map instantaneously, I'll just hold clear and I'll be back on it. But back to flight plan, let us have a waypoint put in. For example, if I click again on my map range and pass across, I can see waypoint Stacey over there. So I'm gonna just scroll in and put in waypoint Stacey. And we've entered waypoint Stacey, but currently the aircraft still wants us to go by this arrow to Astoria. In this case, we want to go from Astoria to Stacey, so what I will do is I will highlight Stacey, I will then do the same as I did with the PFD, but in this case an MFD, click Menu, and I get the options to activate the leg or change significant other things as well in the flight plan, but in this case I just want to activate the leg. Now I've activated the leg, and we can see that we now have a magenta line for GPS function towards waypoint Stacey in this case. So with that done, let's just say we wanted to come back to Astoria. We've just gone out to do some maneuvers around Stacey, and then we're going to come back to Astoria and we're going to try some approaches. So in this case, I'm going to put Astoria as well here. We've now got Astoria. So now if we go back to the panning screen, we can see that it's thinking we're going to go to Astoria, from Astoria to Stacey, and then we're going to make a U-turn and then come back towards Astoria. But flying this to Astoria may not seem as optimal for us as we want, so we might want to do an approach. In this case, I'm going to highlight Astoria, press Procedure, and then I'm going to select an approach. Astoria has no arrivals, but we do have approaches, so in this case I will select an approach. And it's the same exact process for departures, for arrivals, as you do with here. You simply select your approach. It will bring up your options. You select which one you want. In this case, let's say I wanted to do a GPS approach to runway 26. I would then enter it, choose my fix. In this case, I'm just going to choose vectors for simplicity, and then minimums, which can be done as well on the primary flight display, timing and reference, but in this case I will do it here. Scroll wheel smaller to activate it, and then I will choose my altitude. In this case 200, but I have not checked the chart, as this is just an example. Now once you press enter, it will give you the option of if you want to load or activate it. In this case we don't want to activate it because it's going to send us immediately to the vectors, so we're just going to load it and have it sitting in our flight plan. Now if I go to flight plan, we will see we've gotten from Astoria to Stacey, and then we're going back to Astoria, and our approach of choosing is the approach to Astoria, runway 26, with all the waypoints and altitudes put in from what it knows. Now we look at the integrated communications panel. This panel is the way to use your radios / navs, allowing you to talk, navigate, as well as choose different options, identify radios, but identify different stations by their Morse codes, and so forth. So for example, to start off with the comms, we've got COM1, COM2. COM3 is currently not simulated in the simulator, but between COM1 and COM2, you can either select COM1 to speak with COM1, COM2 to speak with COM2, but if you wanted to, for example, speak on COM1 and listen to an ATIS on COM2, you can then click COM2 here and not mic, and it will allow you to both speak on this radio, and if ATC contacts you, and listen to the ATIS for getting extra information as you're about to land at your airport. If a noise becomes too bothersome to listen to both at the same time, you simply just turn off the one you are not interested in. Moving further down, we've got the marker mute. In this case it's currently lit, which means if we fly over marker beacons on an ILS, we will get the audio tones. Normally I turn this off just to save a headache unless I'm doing an approach. Moving down further, we've got DME, NAV1, NAV2, and ADF as the functioning items. So again, in this case, if you were to want to listen to the identifiers for DME, you would activate it and listen to it. Or in the case of NAV1, you'd activate it to listen to the Astoria Morse code if you would like to listen to that. ADF and NAV2 are exactly the same as the other two. And then we go further down, we've got volume buttons down here, which are supposed to work on VATSIM if you have XPilot using. Otherwise, for the meantime, they are not simulated. And then last but not least, on the integrated audio control panel is the display backup, which allows you to use reversionary mode in case one of your displays fail. The G1000 should automatically do this, but should it not, you have got the manual backup button as well. Clicking it one more time will transfer the G1000 back into its normal state. Now let's talk about some of the other formats that the G1000 comes in. Now we're sitting here in an SR22 on the ramp at Astoria. The differences between most G1000s, still in this case we've got the two display screens, but instead we're missing the audio control panel, but we've also supplemented in a keyboard for the G1000, alphanumeric keyboard, as well as most of the buttons on the bezels have gone and have moved down here to our keyboard as well. The autopilot as well has also moved down here in the GFC 700 form, which is also similar to the GFC 700 on the autopilot panel, and our audio control panel in this case has moved here to the Garmin GMA 350. Functionality is still identical. As you can see, it's just a little bit switched around. Some of the extra features that you might find on other G1000s that are not on the default one, such as synthetic vision in the case of this one, which can be found under PFD and a new option set in there. Or in the case of the MFD, more options can be added in there, such as engine, to give you more system information. Or in the case of the map, you can also get a profile. One moment, it had a bit of issue. And there we go. We've got also a profile to give us terrain vertical awareness on the MFD as well. Other aircraft can also be included with a checklist form, which can be added in, and you can do your checklists on your aircraft. And I click exit. There we go. Again, operating the G1000 still forms off of the same button features, such as here, even though the buttons may be gone, they're right here, as you can recognize the direct to, the menu, the flight plan, procedures, clear, enter, transponder buttons for ident, com, nav, and so forth, all still being relatively identical to how you know it. And now we come on to our last G1000 configuration that we can also get, is the 3-skin version, in this case with 2 PFDs and an MFD. In this case the MFD has gone from the 10-inch display to the 15-inch display, and it still retains the keyboard here, though in a slightly different layout, with the autopilot again moved up to the top here for the GFC 700. Again, the GFC 700 remains roughly the same in terms of features across the board. The alphanumeric keyboard also remains roughly the same, with direct, menu, flight plan, and procedure still retaining their normal spaces. Clear and enter have shifted to the bottom to be a bit more user-friendly with the keyboard. And again on the PFD, now we've retained our 6 main buttons with the FMS scroll. But again, along the whole display, along the bezels, the top still retains roughly the same information as the standard G1000, and instead of the GMA 340 like in a Cirrus aircraft, it retains the same audio control panel on most standard G1000s, but one on the left and one on the right for each respective pilot. And with all G1000 aircraft, there must be standby instruments. In this case, on this aircraft, we've got an integrated standby instrumentation system. On the Cirrus, we've got analog gauges, and on the Cessna, we've got analog gauges. Alright, so now we're sitting over here on the ground at Astoria, just holding short of runway 26. So we're going to do a little bit of a local area flight with the G1000. If I go over here to flight plan, let me just change the daytime, it's a little bit darker. Much better. Okay, now we can see a lot better. So if we go over here on our flight plan, I've got our departure airport as Astoria. We're going to do the departure on the Astoria 3. We're going to follow it as per the chart, and I verified to make sure it matches the chart. We're just going to climb out to 420 feet. We're then going to make a right turn, and then climb to 2,000 feet, making a left turn back to the Astoria VOR. I've then gone ahead and put a waypoint Jupdo, which is going to take us a little bit to the northeast and just take us right out over the bay. And then from there we'll begin doing some programming for our procedure for landing and approach. And then we'll talk about more about the GTN features that we just covered in the previous section of the video and just put it all together. So, currently holding short of Astoria. If I'm on VATSIM, I'm going to go ahead and tune my Unicom frequency of 122.8. I'm then going to switch it over to active, and I'm going to announce on the traffic Astoria traffic, Cessna 172 Sierra Papa departing runway 26 at Astoria traffic. So, with that announcement, basically I will, from holding short, I'll finish run up as needed, and then we're just going to line up, we're going to take off, and then we're going to follow what the G1000 tells us. In this case, it's already set for GPS, and you can see by our course and our GPS, which is essentially matching runway 26, or in this case 258. And we can verify at the top here, we're going from runway 26 to our next waypoint, or the 4,420 feet indication, which is 0.8 miles away from where we are right now, and its bearing is 261 from where we are right now. Notice how it says 261. It says 258 down here because that's the course we're at, but we're slightly to the left of our course line, so automatically, if we were to line it up, it would be 261. And then on the right side, we've just got a few extra indications such as ground speed, direction, track, and ETE once we start moving. I've got Astoria tuned in as well, so we'll also have a look at that as we fly outbound from it. We'll probably try and fly an outbound leg from Astoria itself using the VOR. And for now, that should be all. I'll go and hit my transponder and just turn it on to alt, confirmed by the green. Again, anything sort of radio related or radio signal related, such as transponders, comms, and VORs, all in green. Alright, so release the parking brake and let's get going. I'm just going to go ahead and click the flight plan button, or I could just hold it clear and it will take me back again to my page of choice. Lining up now, and we can see that our course also now says 261 down here and as well up here, and we can confirm for runway 26. Oops, I accidentally clicked one thing too far. I'll just go press clear and back to my map screen. So now we've verified it's the runway, we're on the correct runway. We don't need the taxi diagram anymore, so I'm going to go ahead and zoom out a little bit so we can see a bit better, and we're going to go ahead and go full power for takeoff. Landing lights on, confirming that we're taking off, and off we go. Bit of right rudder. I'm sure all of you are used to that from your instructors telling you that. More right rudder. 55, and we're rotating.
FSE flight not started.
Alright, and now it says here at 299 in 4 seconds, indicating we'll have to turn to a heading of 299, in this case now. And once we officially get there, we'll begin our slight gentle turn, and we'll basically change our GPS heading from where it is. There we go, it's switched to now 302 in this case, because it's adjusted and now knows we need to be around 300, 302 for this next leg. Go ahead and just keep climbing to 5,000. At the moment I'm ignoring if there's any constraints on the departure, just for the sakes of focusing and just saying what's happening with our G1000. So at this point we're well above the restrictions, 1,000, and in most cases, depending on your G1000 manual, in most cases pilots will turn on above 1,000 feet. So in this case I'm going to go ahead and turn on the autopilot. So first what I'm going to do is I'm going to click the modes I want, in this case which is nav, which is going to give me GPS. The flight director says we're still flying the right way. At the moment it's pitch, but I want to be climbing up, so I'm going to climb at my cruise and click flight level change. G1000 letting me know again, we're going to have a left turn to 113 in 7 seconds. But for now, I'm good, so I'm just going to turn on the autopilot. I'm going to let the autopilot handle it, so it's now going to go now, which means it wants to start the turn any second now. But obviously autopilot will be a bit more fine-tuning, and as soon as our HSI changes, we'll begin our turn. In this case, now distance 0, it's changed, and we're going to begin our left turn, and it's going to keep turning with us all the way around until we are on the heading. We should be towards the Astoria VOR at this point. Okay. Just a nice gentle climb out. Hopefully should be fine with clouds, even though we'll just be IFR anyways for the most part. So we'll just follow what our instrument's telling us based off the indications from that. Alright, so now we're currently on our way inbound towards Astoria. Just going to zoom this out so we have a better view of everything. So currently inbound towards Astoria. So just to confirm that we're heading towards Astoria, just in case we will not trust the GPS or we had a GPS problem, we'd simply just switch these over from VOR from GPS to VOR1, but now it's going to try and find that track, but we just want to be on the direct radial straight in from where we are, so we're just going to simply push that in to center it up, and then it's going to try and maintain itself on that radial inbound. In this case, the radial would be 274, because remember, radials are out from the VOR, and inbounds are bearings 2. In this case, 094 is our bearing 2. But we've confirmed that we are going to Astoria. We can see it's green up here, lit, and verified to be Astoria. And if we bring up our PFD, we can bring up one of our bearing information, so the RMI needles, and it will give us also distance in slant range to Astoria. In this case, for number 2, I'm going to leave it on GPS, so it also lets us know, and we can match up to Astoria GPS location is 0.8, to the radio signal, again, is 0.8. So all of that is fine. I'm then going to switch over to GPS so we can turn for our next one and push autopilot back in nav, because it has decided to not longer recognize that we are flying GPS, and it has gone to a roll hold mode. So I'm just going to click nav, it's going to go to GPS, and it's going to begin its turn to fly its course outbound. Also, we got a blue warning and chime telling us that we're approaching our altitude of 5,000 feet. So in that case, the aircraft will automatically level off, because you have the altitude capture system is highlighted in white. So at the moment we're just going to keep pitching for 87 knots, and then afterwards it's going to level off at 5,000, and that ALTS will turn green, indicating that we're capturing the altitude now. And there we go. Altitude capturing in progress, 5,000, and then alt arm, which means it will hold the altitude, is been armed and ready in white, and now once we're at altitude, it's going to hold it at ALT 5,000. At this point, I'm just going to bring back the power a little bit, because we don't need that much power. So now we're flying outbound from the Astoria VOR. I'm now going to quickly just do a quick plug-in of the approach, which I have already preset. So I'm just going to click procedure. I'm then going to head and scroll over to approach, select our approach because our airport is the last thing in the flight plan. From there I'm going to pick the RNAV 26. So this says try something a little bit different and use the GPS functions, and then maybe we'll try the ILS functions as well. From there I'm then going to choose Kilo Alpha Romeo Papa. And is this something we want to fly a course for Russell? Yes, I would like to fly a course for Russell, so we can show some more features of the G1000. And the bar altitude for the minimums is 264, so we'll put 270 for a little bit of buffer and safety. From there, I'm going to click load. Now another thing with the G1000, we're just going to keep flying towards KST. It's still going to, after we reach Jupo, it's going to turn us back and we're going to fly towards Astoria. The problem with that is that it's going to take us to Astoria and not the beginning of the approach. So let us say ATC vectors you for the beginning of the approach. You will not want to head over to Astoria. In this case, if ATC has already cleared you for the approach well ahead of time, you can simply just delete the waypoint Astoria. Or if ATC is not vectoring you properly and has not given you the clearance to your approach well ahead of time, you can always hit procedure and then activate vectors final or activate approach, and it will sequence it to head directly to the first waypoint on your approach. But in this case, we'll let the system do it automatically, so I'm just going to clear Astoria as the next waypoint. And automatically afterwards it should sequence for the hold or the procedure turn at the beginning of our approach. If it doesn't, I'll just simply hit procedure and activate. But essentially it should on most G1000 systems. Arriving at waypoint, warning us in white. So this time it's not going to sequence through because that's the last waypoint and it doesn't see anything else further. So once we hit that waypoint, I'm just going to vector us round using the heading knob. And I'm just going to first sync it up to my position, and then I'm going to turn right towards a heading of about 120. So now we're past Jupo. We got no more waypoints, so I'm now going to press us into heading mode, because as you can see, there's no more waypoints. The aircraft is just going to essentially try and maintain its roll. It should just say a roll indication, but right now it's just maintaining roll, and it's going to maintain altitude, but no other information will be given. So in this case, I'm going to hit heading on the autopilot, and it will begin a gentle right turn towards it. Now because the procedure hasn't sequenced, I'm just going to go to procedure and activate approach. Once it's activated, it's recognized, GPS recognizes the first waypoint's direction, so in this case I'm just going to hit nav and take it back to give it over to the GPS to then fly the aircraft, to fly us there. So now is a good time for us to take a look one more time at the approach plate. So if I open up the approach plate, this is the approach for Astoria. So currently we're expecting to be at Kilo Alpha Romeo Papa at 4,500. Right now we are at 5,000 feet. Let's say we were cruising at 11,000 or much higher than we would be, and we'd want to figure out when our top of descent is to be the most efficient time to descend. So in this case, we can simply head over to here and head over to, for example, here, if it's already set 4,500 as it is part of the approach. But if it wasn't set there, we'd have to scroll and adjust our altitude as necessary. So in this case, we're going to leave 4,500 as the official. Enter it, and then we're going to scroll all the way down past our approach into our current VNAV profile. So if I adjust this, our current VNAV profile says it wants us to be at 4,500 at Kilo Alpha Romeo Papa. Our target descent speed, or target feet per minute, is 463 feet per minute if we're doing a 2.3 glide down. In that case, top of descent will be in about 5 minutes. So that's where our top descent marker is. It's also letting us know that by a marker, a circular dot, if I can scroll them. So it lets us know by this circular dot on our active flight plan. This little white circle. That is basically the indication of where our top of descent would start. At that point, it will start descending us down to 4,500 to be at Kilo Alpha Romeo Papa by 4,500. But in this case, if we wanted to descend at a sooner time, so starting earlier, we would reduce this number down to say 2.6, and you can see our top of descent marker moves further along because it's a shallower descent. But if we wanted to say a steep descent, we can move it up to say a 3-degree glide path, such as our approach, or even steeper if necessary, up to 4 degrees, and it will give us the target feet per minute and how long it will take us before we need to start descending. But for now, I'm going to do a very shallow descent, and we're going to do it from well far out at 1.5 degrees, and it will take us 4 minutes before we reach top of descent, and we're going to descend at 278 feet per minute. Other things such as other things on the bottom of the soft keys that you should know about is the view, which is simply just to change the view of the flight plan. So we can change it if we want it from narrow to a wide flight plan across the top. We can have it from leg to leg information, or cumulative, which gives us total distance from where our current location is. So in this case, from Stacey to Ubix, it's about 7 nautical miles. But cumulatively from where we are right now, it's about 38 nautical miles of travel that we have to do. But I'll leave it leg to leg for now. And over here at the bottom, these extra profiles, because we have our flight plan set up, we can either cancel the VNAV altogether and erase all the information and delete our top of descent, or we can VNAV direct, which means we can start a top of descent from where we are right now, and it will automatically just use, at this point it will probably be really shallow, but it will probably be around 0.3 and start us descending and say descend now, and we could click the autopilot's VNAV descent. But what we're going to do is we're going to leave it at 1.5, and we're not going to click VNAV descent. We're going to click flight plan to bring us back to the map. And what we're going to do is we're going to prepare the autopilot for what we need for the VNAV descent, which is by selecting our autopilot selector to 4,500. Or in the case of our approach, since we have got multiple legs heading downwards until 1,700 feet, we can just also click it there. We can also scroll it. If you've been cleared for the approach, you can scroll it all the way down to 1,700. Click VNAV to arm VNAV, and it says there VPath has been armed, and it will descend down as necessary until you reach 1,700, where it will maintain that following the constraints given by the VNAV profile. And now we simply just wait until we reach VNAV intercept. Alright, so we're now approaching the VNAV descent. As you can see, we've now gone VPath active, and our indicators saying how much feet per minute by the carats of the magenta. So in this case, that's our descent carat for VNAV, and currently showing we're on the VNAV glide path heading downwards. So I'm going to just bring the power back a little bit, and the aircraft will adjust as necessary to maintain it. So in this case, we're entering the hold, which is the next part of the procedure turn. So it should fly us in parallel. For those of you who understand how holds work, it will fly us in, fly us back along the path, and then make us a left turn and bring us back for the approach. So at the moment right now, while we're flying towards the approach, I'm now going to be looking for indications on our annunciators. We're going to look for, as well as the switching of active waypoints. I'll bring the flight plan up here in the corner just so we can view as it switches active. Currently we've reached our descent to 4,500, and the aircraft is going to shallow it off and maintain 4,500 until it's time for the next descent. I'm going to add some power back in. So at this point it says hold in parallel, so we're going to hold parallel, fly outbound, and then make a left turn to fly back inbound towards Kilo Alpha Romeo Papa on the inbound leg. Alright, and now we're turning back for the hold in parallel. We're just going to make a left turn heading backwards towards our inbound bearing of about 260-ish. Now if you watch here as we're making the turn, the autopilot is maintaining that standard rate turn. How we can tell we have a standard rate turn is because we've got this magenta line coming off of our HSI going up to the standard rate turn marker, or the half standard rate turn marker is the second one next to it. The standard rate turns indication really helps when trying to do your holds and maintaining your 1 minute timers as you do 180 degrees. And now we're flying back inbound to Kilo Kilo Alpha Romeo Papa, at which point the aircraft will then sequence its next portion for the next waypoint. Looking back up at our flight, our AVITAB, we can see that we're then going to descend now from 4,500 to 3,800 by UZIPI. So at this point the VNAV is automatically set and ready for the next descent point until we reach 3,500, not 1,800. That is my mistake on that one. So once 3,500, we'll then hit on the approach and prepare to descend down with the virtual glide path from the GPS signal of our WAS GPS. And we're now heading direct UZIPI, and we're waiting for our glide path to arrive to the center, and the aircraft will begin descending down with it. As we can see again, because we're flying slow enough, it has enough time to generate and show a top of descent marker again in front of us. The 1,000 foot above warning, or 1,000 to go before our selected altitude, has horned off. And I'm just going to bring the power back a little bit so we don't descend too fast. And the G1000 is going to do another level off, and then now it says direct to 260 now, indicating our next waypoint. At which point we've now switched over into LPV, which is the approach phase of our GPS approach. In this case, you can see as it went from terminal or en route to LPV for localized performance with vertical guidance. At this point now we have, instead of a glide path, instead of a flight path for VNAV, we now have a glide path to descend with the approach mode. So what I'm going to do now is I'm going to go ahead and click approach as we're heading towards 2,500. And it's sequencing us, telling us in 10 seconds, direct 260 for our next waypoint. In this case, we're not worried about that, and we've clicked approach. So we can see ALTS is active to hold us at 3,500, and then it's going to go active into glide path with for vertical guidance. And now we're GPS autopilot glide path, which means we're now descending with the glide path all the way down to the runway. At this point, you'd probably want to already be configured. I've not done that. Shame on me. So I'm going to quickly slow down. And I'm just going to go below 110 flaps to 10. And we're going to keep 110 all the way down, around 90 all the way down to our minimums. But in this case, for the G1000, you can leave the autopilot on up to 200 feet, I believe, with a localizer glide slope type setup, or if a precision approach, and 800 feet on a non-precision approach. Depending on which regulations you follow, if you follow the FAA or EASA, those could mean two different things in certain cases. But for now, we'll be following the FAA laws, and this is not a precision approach, so we will disengage the autopilot at 800 feet. A few things to consider once we disengage the autopilot and begin our landing approach. If we did not have the runway in sight due to bad weather or horrible visibility on the ground, and we decided to do a mist, we would simply climb up to our missed approach altitude, which, if I check the chart, is straight ahead to 5,000, then direct Stacey, then a left turn back, and that would also be all sequenced in the missed approach procedure. So in the case of G1000, it will automatically sequence the next missed approach. It will ask you if you'd like to suspend and maintain what it currently says, or you'd like to engage the missed approach. That will all be done if we did a missed approach, but we will see that on the ground and we will simply reject that option once we've landed. At this point, we'd probably also be letting the people at Astoria know that we're about to land. So in this case, Astoria traffic, Skyhawk 172 Sierra Papa on final runway 26 Astoria. So in this case, we get closer towards minimums, we'd slowly start transitioning our head to looking for besides the instruments to also looking outside of the cockpit and just looking out for our runway environment. And it would be constant back in and back out until minimums. Above, it's gone to white, and then once we reach minimums, it should go amber. And we're at minimums. We're going to disengage auto. We should disengage autopilot a while ago. By this point, I'd be slowing down and bring our flaps to full for landing. Let's keep taxiing a little bit further down the runway. Watch as the GPS will then sequence us to our next waypoint. Unless it doesn't recognize that on this one. Normally it should ask us to sequence to the next one, but in this case I guess it did not. Which is not to worry, it should sequence anyways to the next waypoint once you have to do a go around, so that is also no worries on that. Alright, I'm just going to bring the aircraft to a stop. I'm going to just turn off here. I know it's closed, but we're not too worried about that for now. Alright, and with that, that concludes the G1000 tutorial. Any final bits of information I can give is, say you want to fly your route backwards, you can simply go to the G1000, and as before, we have the different options in menu, such as invert route, delete route. Usually I prefer to delete my routes after every flight just to leave them clean for the next start, because it will remember the route you last put in, and you'll always have to delete it the next time. So that's up to you on how you wish to operate it. Otherwise, thanks for watching.